So, welcome to our talk. I am Cornelio Hopmann,
And I'm Jacob Evans.
and we want to talk about GraphQL, give you a little bit of insights of the things that we've learned in the past few weeks and some other stuff. So, let's start. Whoops.
And Shotogun. I built the presentation software because I thought it would be cool and I didn't support arrows.
So, who are we? We are Node.js developers in an open source group called Hamburg Chimps and are currently working at Cybus in industrial IoT topics. We are GraphQL enthusiasts who want to share their recently acquired knowledge with the community. I've been living in Hamburg for almost 2 years, live a bit further south for about 4 years, and I'm looking forward to stay more time here in Hamburg.
Yeah, I'm Jacob. I've lived in Hamburg for like a few months now. Really enjoy it. Hamburg's an awesome place. Really like working here in Germany. Kick ass. I enjoy getting mad while playing board games or any kind of game, and I enjoy learning new things and new technologies.
So let's get started. What is GraphQL? GraphQL is not an implementation, just to start with it, and it's not owned by Facebook. If you heard, okay, yeah, the guys at Facebook created this, yes, but they don't own it. What is GraphQL? GraphQL is a query language, and most importantly, it's a specification. And the good thing about not being an implementation in itself is that you get the power of multiple people implementing the spec. So you have multiple open source specifications. The first one was the one that Facebook did, Relay, but we are currently using Apollo as an example, that you don't have to use the Facebook related stuff if you don't want to. And like as I said, it's a specification and not an implementation.
Is Apollo by Facebook? Or?
No, it's an open source community.
It's an open source community.
The guys that did Meteor Meteor are the ones that developed it, and they're the main contributors to the software. But it's open source, and a lot of different people contribute to it. And we fell upon Apollo versus Relay after kind of comparing them, just because the community, the tooling, and they're really taking advantage of like the newer. Like it's funny because Relay is made by the React guys or made by Facebook, but they're not really taking advantage of like what the React or the larger JavaScript community does, at least in my opinion. Apollo really is. They're really pushing the envelope of what you can do with the tech. Yeah. So that's why we kind of chose Apollo as the one that we're using and the one that we use in our projects.
And those are the ones more vocal in the community. Those are the ones that are pushing the most blog posts at the moment. You have the most references on YouTube are using also Apollo. So it's kind of the go-to thing right now.
Yeah, their documentation is awesome. I can like if you want to go like we have some resources in this repository we'll send out later. But if you want to go learn more about GraphQL and how to do GraphQL, the Apollo website is awesome.
Yep. So let's get a bit into what I told you, that it's a language query specification. So it's a strongly typed language. So we have different types. We have the normal Scholar types. That would be the normal integer type, float, string, Boolean. Then we have a special thing called the ID type, and it's a special kind of Scholar type in that sense that it's used to fetch or refetch an object, or use as a key for caching that object. Going to talk about that when we get into the front end side of stuff. And the only thing that you need to take care of it is it has to be serializable to a string. So if you use some alphanumeric stuff, then you're good to go. And or if you use UUIDs, you're also good to go. So that's the only important thing about IDs. The other cool thing is that you can create your own types, as we see here. I created a city type, and
We had a question? Oh, sure.
oh, sorry.
How is that? Can you see that a bit better? Yeah. Maybe that for a bit, and we can scroll with that. Yeah.
So you can define your own types. As you see here, I'm using the ID type for ID. The exclamation mark means that it's a required property. If it's missing, then it's an optional property. We have some examples when we get to the tooling, how that plays nicely with everything, and you have another type of object. So that type of object is the input object, and you use that if, for example, once you have more complex objects that you want to query or to do mutations with. I'm going to show that in a second. Then you want to separate the normal objects from the ones that you are using to get the data of. So, and you have lists, and they are demarked by the square brackets. So these are not all your types. You have more complex types, but to start with GraphQL, these are the most basic types, and with them you can do a lot.
What does exclamation mark?
That means that it's required.
So like we'll get a bit into it more later, but like when it's in a typer like basically what you get back or what you need to make something. So when you have an exclamation mark, you said if you were ever going to make an object of this type, you have to give me this kind of data.
Or
Or with an input, you're saying if you were ever asking for something, you have to give me this information. It's not optional. You have to give me that. That's what the exclamation mark means.
Yeah. And if you see it in here, I'm actually defining another object. So another type of object. So objects can be complex and have sub-objects. And GraphQL brings a cool thing with it.
One more question to the lists.
Yep.
Can they? So you have said that the Scala types are different types. So is it just a list, or is it a list of different types? List of booleans, list of strings,
List of different types. So.
No, you mean
you mean if the list can have different types of themselves? No, you have here you have a list of districts.
So it's an object.
Yeah.
It's a rule of GraphQL that everything has to be able to be reduced down to Scholar types. If you have complex objects like city that has a district has to resolve down to a Scholar type. It has to resolve down to like one of the
Can it be mixed types within the list?
Mistype? No, so right here specifically.
Yes, you can, but that's with more complex types when you're using interfaces and that sort of stuff. Yeah, but you're able to. So we have a special type. That's the query type, where you define all your so to say, get functions, the functions or methods that you use to get data out of your app. So the queries are read-only fetch. They can have multiple arguments. And the cool thing about GraphQL is once you do a query, you can specify exactly what data you want to get back. So, for example, in this query, I'm getting all the cities with, if you remember, this was Boolean. I'm gonna get if it's discovered or not. I just want to have the name, the country is a complex type, and I want just the code, the country code from that type. How a response looks like, we're coming to that. So as I said, you can have multiple objects in an object, and how it looks like underneath it on the back end is that you have resolvers for your more complex stuff that give you the possibility to make highly complex or highly relationable queries. So as in the example you saw that I was asking for the country, so I can actually hide that business logic in the resolver and get that item and give just enough data to the client consuming my API. So mutations are just like queries, but with the small big difference that they are used to modify the state of your application, to put things in it. And they also have this property of GraphQL, where you can always specify the things you want to get back. So,
does everybody get that difference between queries and mutations? So they're one is just like the get equivalent, and then mutations are just everything else. Get allows you to specify what kind of data you back, select everything, and mutations allow you to create certain things with input objects, or say this is the data that goes into making an object, and then request back what you want.
Yep. So
cool. So now let's get into some of the tooling of it. We've been talking about like the concepts behind it, but I always find like a good tool, and actually seeing it like live helps out quite a bit. So part of what's really cool about the GraphQL community is not only, sorry, and I'm going to slow myself down here a bit. I'll tend to talk really quickly when I'm excited about something. Part of what's really cool about the GraphQL community is not only are they coming forth with this really cool specification that everybody's supporting, is that they have really kick-ass tooling with it. And GraphQL is one of my favorite bits of it. I'm going to pull up GraphQL real quick.
Wait.
There we go. GraphQL stands for the GraphQL IDE. So a lot of the time when you're making these mutations or these queries, you want to test out what's actually happening on the backend server, or whatever points you're hitting to get this data back or to create new things. GraphQL is kind of like, I would say, or GraphQL is kind of like Postman, if you've ever used Postman, but Postman for GraphQL. It allows you to test these things out and actually see the results coming back, and then use these same queries and mutations in your actual live applications.
Postman on steroids.
Postman on steroids. It's an excellent way to put it. What's really cool as well about GraphQL, like with the specifications that you're writing with types, input, and everything else, is that we had this kind of conversation out there as well, that it's almost kind of like Swagger. Who in here has used Swagger before? Right? Swagger is kind of like the specification for HTTP. You say, these are the arguments going in, this is what you can expect back. Like, when you write a GraphQL specification with these inputs, queries, and mutations, you're almost writing a Swagger file, but for GraphQL. And what's really cool is you can take that same file and put it into GraphQL, and it will generate the documentation for you. So what's really nice about this is you're not having to look at like documentation, endpoints, and trying to figure out what returns what. You can pull up GraphQL, and you can just immediately start playing
typing,
around, and you can see what data you're going to get back. You can just get right into the nitty-gritty. So, for example, I have this shopping list application that I've built before. If you want an implementation reference for a simple GraphQL app, it's going to be in this repository at the end, and I have it started up. And let's say I want to make something. So we have our root query type, and again, queries allow us to get data, and then we have a mutation type, which allows us to make data. So I just started up the application for the shopping list. I don't have anything yet. So I'm going to go ahead into the mutation, and let's see what kind of mutations I can do. So you can see I can create an item, I can update an item, and I can delete an item. And you'll see that these have input objects, which tell me what needs to go into actually making these, and they have response objects, which actually come back from this.
Input objects, the queries and mutations, they can have multiple arguments, and once you have lots of arguments, it's easier to organize them as an input object. You can also reuse input objects in multiple places. So if you want to try out your code, the best practice that the community came up is using input and input objects.
Yeah, they're like type definitions in Swagger. Right?
Yeah.
Cool. So let's go ahead and try this out. I'm gonna make a create item. So to start out with, you use curly braces here. And to specify that I'm doing a mutation, I'm going to write mutation in front of it.
You can even give it a name.
Mutation, this is true. We could give it a name. I could call it, this is going to be my create item mutation.
Yeah.
And then inside of it, I'm going to call this specific mutation create item. So I'm going to go ahead and, again, GraphQL being as awesome as it is, it will start to autocomplete, create item. And again, I'm going to put parentheses. This is going to be my arguments for whatever this mutation is. It's going to autocomplete for input for me. And I'm going to put in that the input object I'm giving it is going to take these values. I'm going to go ahead and click on the type for create item input to see what needs to go into a shopping list. So it needs a name. So I'm going to go to the store and I'm going to go buy some milk. What's the price? How much does a liter of milk cost?
I don't know, €1.
Yeah, yeah.
And it's actually
an int. Yep.
Yeah.
1. And then it needs to take a user who's ever actually using our application. So I'm going to specify a user here, which is going to be an object. And then I'm going to go ahead and click on the user type to see what goes into it. And again, we have these complex objects, but they always have to resolve down to these scholar types. So first name, I'll put my first name here as Jacob. Last name as Evans. And there we go. I can actually create an item now. I'm going to go back up the list here. And then I'm going to say back when I actually create an item, this is what I want to get back. So if you see here, and I'll go back here, this is the response object of whatever my mutation gives. And if we look at the response, I can get a Boolean for whether or not my operation was successful, and I can get the message from the server.
We define this response. That's not part of GraphQL. We are defining these items.
Yeah.
So
you can, again, and you can send back whatever you want to. This is just something that I've made. So if we look here, this data that we've gotten back from the server, the create item mutation resulted in a success true item was created. And I'll go ahead and I'll just make another object here, or another grocery item. Let's say I want to get some eggs. And eggs cost, like, let's say €2. But with the same user. And I'm getting back again, create item, success, true, message, item created. So now we've tried out one of the mutations. You got a bit of a feeling for how the mutation works. Let's go ahead and try out the query. Do we have a question? Go ahead.
Did you create 2 users as now or 1 user?
One user with the specification.
with this implementation in our backend. It depends on you how you process that. But in our case, we are just having one user.
If it did take multiple users, you would see square brackets around this dictating that it was an array of user inputs and that you could provide multiple users. Because you don't see square brackets, my implementation only takes one user.
So is this language JavaScript, JSON objects, or because you use the
Sort.
You know that this type is string, but you still use literals for quoting the string and so on.
Yeah, I think it's a subset of, or a superset of JSON is what it's defined as.
Sort of.
Sort of.
Based on JSON, but it's an own implementation.
Yeah.
Yeah.
Yeah. If you were to, if you wanted to update, for example, the price of X goes up to €3.
Yeah, we could go try that. We could go to the update, and the update says that it needs the ID back. The ID back to actually get the ID of the item. Since I made a quick response, we're gonna have to do a GET request real quick, or a query real quick, so I can get back the item. So let's do that. I'm gonna go ahead and go to the query types, and then I'm gonna get back to the update.
Yeah, no, okay, let's jump into that.
Yeah, no worries. Okay. Yes. So I'm gonna go and let's get back all the items that I put into my grocery store list. And again, this living document of what my GraphQL specification was, you'll see I have item, items and users. And let's go ahead and I want to get back all the items that I put in my grocery cart. So I'm going to go ahead and delete this mutation. And I'm going to say query. I want to get a list of items. And it takes the first name, last name.
And again, if this was a more complex query, then you would use an input type.
Yeah. With it being just so simple here, I didn't use an input type, and just to also show you can just use an array of arguments as well.
Yeah.
And you'll see here back that it sends back an array of items. That's what the square bracket here denotes. So I'm going to click on the item, and I can ask for anything that I want to get back. So first of all, I'm going to need the ID for the update.
Yeah.
So let's just ask only back for the ID. I don't need anything else right now. I just want to know what the ID is.
Oh, and the
of.
name.
Or let's get the name as well.
Yeah.
But I don't actually care about the price of anything. I just want to see what I have in my grocery cart. So if I go ahead and execute this, you'll see back that I get data, which has my items query, and it populated all these JSON objects with the ID and what their name is. Let's say now that I actually care about the price, I can go and I can ask about the price. And now I can get the price back. Let's say I want to know what user actually created them. I can go and I can specify.
It's a complex object, so we can specify more stuff that we want to have from the object. Can you take the, we just want to have the last name.
The last name?
Yeah.
Oh, we can do that as well. And there we go. So you can ask specifically for what data you want back instead of just getting everything by default. And we'll get into this compared to REST and HTTP a little bit later, but just kind of an example there. But it was requested that we update the grocery cart. So let's go ahead and I'm going to update. Go for it.
Yeah, a second.
I'll go for it.
Can we actually limit results like price, not more than something?
You will need to implement that logic, yeah, but you can surely do that.
Yeah.
So basically it depends on backend implementation.
Yeah.
Yeah, it's basically an abstraction over your backend implementation. So if you wanted to get all the items in your cart or with a specific price, you would then go ahead and in this query, you would make a like a cost or like an items or like let's say an items, but you would give it the arguments of like min cost and max cost.
Like a range.
Yeah.
Yeah. Probably you could. It would be best then to use an input type.
Yeah. Cool. So let's go ahead and I'm going to go to mutation. Let's go to the update, and I'm going to go ahead and delete this. So I'm going to make a mutation, update item, and let's see real quick here what the update item takes in. It needs an ID, and you see here that it actually requires the ID. The ID is required because I need to know what specific item that I'm updating, so I'm going to give it an input, ID, with the ID of, let's say the price of milk has gone up because everybody loves milk. And let's say, yeah, we're updating the price, so let's say the price has gone up to 4 euros.
Yeah.
And then we're just going to get back the whether or not this was a success. Okay, and it's successfully updated. Now, this will give us an opportunity to test out our query here. Let's get back just the one item of the milk and see what data we have on that. So I'm going to write a new query here. I want to get a single item back, and that takes an ID. And it returns an item, and an item has, let's say, a name and a price. And we got name is milk, and the price is 4. So we successfully mutated it and then requested the data back. And again, so this is just kind of showing off the tooling and what it's like to actually use GraphQL and using mutations and queries. We'll get into like what that looks like in further implementations. But here's the tooling for you, and that's kind of like a live demo of what mutations and queries look like. Was there any questions on that before we moved on? Cool. Go for it.
What about databases and support for different databases, and what database are you?
That's not part of the GraphQL server. So if you're you have all the possibilities that you have with Node.js to connect to a database. So like just a normal web server. right? Like where you are the one managing the connections to the different data stores. So I don't know if that was your question.
So, like, how does it, like, if you wanted to connect to multiple?
Okay. Yeah, right. It's basically what I understood when I read first about GraphQL. I haven't used it in many applications yet. Is that it allows you to connect to different databases and then join tables from different
Oh yeah,
storage
yeah.
devices,
We are
databases,
yeah
whatever,
we
text files.
we're going to show some of the how you can structure your project and code to be able to support that more easily. Like what they are trying to like one of the main selling points of GraphQL is this kind of all grabbing API on top of some other things, right? So, but we're getting into that.
Yeah, and that's the idea with like kind of the resolver logic in this. Again, so this
The
is
resolver and connector logic, yeah.
and we'll get into that a bit later. But the idea here being that you make a request for this, like this kind of data, and when you get into the actual logic of how the GraphQL server is written in the back end, it doesn't care where it gets the data from. It just collects everything, puts it in this data model, and then shoves it back out to you. And we'll get that a little bit more into the back end implementation and the back end logic of it.
Yeah. Cool. And good thing, yep.
What happens if you have a required input and you don't give all the input that is required?
Oh yeah, you want to get rid of the ID?
We can try that. Syntax error.
So since it pulls the specification of what should go in from the server as well, it won't execute any commands it sees as invalid syntax.
And then you have the same as functions that you have kind of, because you said you have required optional parameters, so you can have signatures in the backend where you have optional parameters on the input.
Yep.
And if you give them, maybe the answer is different than if you don't give them and so on. So
Exactly.
So
Exactly.
it's really like a RPC system with a return value filtering if you want.
Yeah.
Yep.
Do you need to write filtering, sanitization, whatever to avoid?
For the things back, actually, that's one of the coolest things about that is that the server actually just returns what the person asks for. So if for example, if your user does not, if you didn't specify in your GraphQL file that you are able to get the password, then then your user is never able to get that back, if that's your question. Like if it's not defined there, it's not going to show on the client.
Yeah, I got that the filtering of the data from the server is,
Yep.
is on the side of the server. But what if in the field of ID I will write SQL statement drop database users?
Oh, you're saying does it do like? So you're saying
Does it sanitize for injections?
no? The sanitation is up to you. Like
Okay, got it.
yeah.
Thank you.
So like again, so like think of like GraphQL as a layer that sits between you, the client, and then whatever databases that you have or whatever result you have. We'll get into the logic of the backend a little bit more, but the idea is that your connector or whatever is actually connecting your query or mutation to the logic itself, like a REST client, a Postgres database, or like an let's say like AWS. You need to then write the specific logic of sanitation or anything else, or use your own tooling for it. This is just an abstraction layer over the top of saying, I want to get some data, and I don't want to have to make a million requests. I just want to make one request or one mutation and let it fan out to all of the different types of data that I have, such as Postgres or whatever, and then just get something back. I don't care where it goes or what databases or what interactions you have, whether or not it's sanitized. GraphQL doesn't care about that. It just gives you this abstraction layer in order to get everything back and to send things back, and to mutate everything at once and let it cascade to the different types of things that you have.
One more quick question in the beginning. So say you had, because you said you implement your backend yourself. Say you had an I don't know which technology, it doesn't matter actually. So, but you get a query for example, in your backend. In your backend you have an exception.
Oh, yeah.
And you never answer. So what does GraphQL do for me there? I mean, how does it handle exceptions on the backend?
Well, you do actually get an exception thrown to the client. Like if something not working and you return an error, then the client is gonna get that error. But if you swallow the error, then in that case, it can time out, I guess.
And time out, so you may get not an answer immediately, but after some time you have normal.
Yeah, and then your payload, like whatever you send back to the user, that's also kind of your responsibility for how you form it. If you, again, you get to decide what the user gets to see and not to see. So let's say if you get an exception thrown, your GraphQL logic to say, okay, one of my connectors failed, this is the payload that I'm going to send back to them. And you could make, then they could say, oh, I only want to know the status code or the message of the error back. It's your responsibility to define what the user gets back from the error as well. If it was like, if something failed and it just didn't connect, you'd just get like a timeout request or something.
So,
There you go. Yeah. Oh, is this me?
oh, okay. REST versus GraphQL. REST is not that different from GraphQL. GraphQL is just an extension built on the REST interface. They both allowed us to do CRUD operation on resources. The difference is an architectural. The difference is that REST is an architectural concept for network-based software, but has no official tooling or specification. Is just designed to decouple an IPE from a client, and it's actually just a paper that got released 8 years ago. So, yeah, 8 years ago. And GraphQL is it's a query language, a specification, and a collection of tools designed to operate over a single endpoint. So the difference between the whole debate about is this REST, is that REST, or is this, you don't get that. It's a specification, you know what GraphQL is.
And so just like talking a little bit about, before we get into the backend and how to structure your backend and recommendations for that, just a little bit as a front-end guy primarily, like what it's like to work with this. This is kind of, a lot of the benefit of using this comes from people that actually consume the data. So what's the differences in front-end architecture? The thing is, once you, like we see with GraphQL, is that it's incredibly straightforward to fetch data when using GraphQL. Normal request usually requires that, like let's say we're getting a city. We have to say /city/ID, get this back. And then usually if there was a country or some subset of or complex object in that, it would give me an ID back, and if I wanted to get the country or anything back, I would say, okay, get /city, the ID, /country, and it would give me the country object back. And then if I wanted to get the districts, I'd have to do another get request, and I'd have to get that data back. This was kind of the idea with REST, right, is that you would just go URL further down if you wanted to get more complex data types. With GraphQL, you can just enable by saying, I want this kind of data, and it gives you back the data that you specifically asked for. You don't have to hit all the endpoints that you need to make your data or your model to actually consume with your application. You just say to this endpoint, this is the data I want, this is all I care about, and I don't care where it comes from or how the backend devs deal with it, just give it back to me. And that works really, really nicely because it allows the backend devs just to do whatever level of abstraction with the different databases that they do. If they switch from Postgres to InfluxDB or to MongoDB, it doesn't matter to me as long as they send back the same specification file, which is the GraphQL file. As long as they return the same data that I asked for back, that's all I care about. Go for it.
Is then the filtering on the backend side or on the front end side in the case of GraphQL?
Filtering is in the backend.
Okay, so you really reduce the traffic. If you ask for less, you send less. Right?
Yeah, and another benefit of it, it depends how your GraphQL server is implemented, but on the query side of things, queries, and you saw that, for example, city had a country, and that resolving of that complex object is done as asynchronously. So once you hit once you do the query and it has to resolve multiple complex objects, depending on your server, GraphQL server implementation, the server is actually gonna perform that resolving asynchronously.
So yeah, meaning like I can say I want all of these different things from all of these different resources. They cascade down, they all resolve themselves, they come back, they build this data model, and then they just get it one big chunk back to the user. I don't have to worry about all these different parts loading in asynchronously. I can just get it all in one big chunk, which again is really nice as a front end guy. I don't have to worry about, oh shit, like this is loading in later, this is loading later. I can just build this one solid application based off of this data model. And which makes it a lot easier to maintain on the front end as well. Also, React with GraphQL. React kind of really plays nicely with GraphQL, right? GraphQL says with properties, tell me what data to pass down, and I generate the actual component for you based off of the properties you sent down, right? Plays really, really, really nicely with GraphQL. Here's the data I want, give me back the data, populate this component for me. Pretty straightforward with that. They go really, really nice hand in hand. Because, again, GraphQL allows you to say, I want this data, and React says, okay, this is how I want to display this data. And just as a kind of quick example, again, we'll have an implementation if we have some time to reference it. If not, the code will be up on GitHub and you can look at the documentation. But what it looks like is I say, here's my query. I want to get the country and get the country ID and name. And for the actual component, I say, okay, here, and this is the Apollo specifically, right here is the code. I have a query. The query, I'm passing it as country. And then I get the loading, error, and the data back. I want to get the actual country. And here, I'm going to zoom out a bit with this.
Give me a second.
I can't see the... There we go. Oh, yeah.
Oops, sorry.
There we go. If it's loading, I'm just going to return this loading GIF. If there's an error, I'm going to output the error. You can handle the error however you want to. If not, I'm actually going to take that data and I'm going to say, hello, welcome to country.name. And again, I didn't have to hook in Axios. I didn't have to have Redux Thunk or anything else. I just said, this is the data that I want. Make the request, get the data back specifically, and then populate the component with it. It's really nice to develop front end with this, especially with React. Go for it.
Where do you define your endpoint? It's a provider on the top of the...
Oh, in the actual client specification, you just say, here's the, with the Apollo Boost client, you just say, here's the URL for the GraphQL endpoint that I'm hitting, and then any queries that you make will get hit off of that.
Okay, so that's maybe somehow injected into the query component.
Yeah, it's passed down through the provider syntax in React.
Does this support authentication as well?
We have some Q&A at the end for that.
Yeah.
That's a big question in the GraphQL community.
So some talks about code organization. So you said, one of the main benefits that's being promoted by the community is that you can put GraphQL on top of whatever you want, and it's gonna do magic and unicorns, and you're just gonna get the data back that you want, right? But how you do that? And one thing that we find quite useful from some blog posts of the guys from Apollo was how they separated things. And they brought this idea of having connectors to different data stores. So you define your different types. We are using plain text files to define our GraphQL endpoint. And we combine that with some JavaScript to actually have the business logic. So in this file, for example, in the schema file, we have all the different object types that we are able to resolve. And that would be, for example, this is just the Gorilla auth code. We have a grant type, we have a group type. And on the mutation side, we have different functions that change the state. And the way they look inside is you define your different types, and with the example of city, you would then write a resolver for the city, use a connector, and in the connector you put all the logic to the stuff that you want to grab from. So one of the best practices that was put everywhere in the community was that you should try to keep your resolvers small and use the connectors for getting the data out of the different data stores.
If I can just take a sec to clarify that as well, just like to rehash it.
Yeah.
So query has a resource, city. I want to get a city. The city has a resolver in the back end. This resolver says, they're giving me this, and I need to give them back something. The resolver then has a connector. I'm using Postgres. I have my Postgres city connector that says, go to Postgres, this is what they're giving me, give me this back, format it in the correct way, and then send it back to the user.
Yeah.
The connector is the specific thing connecting to your database, whether that's REST, whether that's MongoDB, whether that's any type of resource. The resolver consumes this, and the resolver is called by a query or a mutation to resolve the operation and then return some result. The type files are just saying, this is what any incoming or outgoing request should look like.
Yep.
Does that kind of like help solidify like how you can connect to all these different kind of technologies? It's that there's this middle logic that says, like think about it as like a divier. Somebody said that they wanted a city, so I'm passing that to Postgres, but somebody asked for a user, and our user database is in Mongo. GraphQL, specifically the server, is this middleware, or this guy in the middle that's passing things out to the right guys, getting the data back, and then passing it out to the correct clients. Yeah.
Can you do multiple connections within one query? So you query one database for an ID, and then you query another for the details?
Yes.
That's the thing about that the queries that those are just specified on the front end. How you resolve that on the back end, I mean, if your ID is the same ID in multiple databases, and you can just with that ID get from Mongo and get from your caching or something, then you can just go with the same ID. Or if you can have some sort of more complex logic, in a sense of you're not using the ID, but you're, for example, looking to every group the person is member of, for example. That's a more complex query, and you can hide all that on the back end. And the front end devs, they just get the queries, get me the groups, or this is my query, and this is the data I want to get back. And the backend devs are the ones that are responsible of using the GraphQL server as this glue thing, and pulling from the different data stores and merging it so that our front end can consume it.
And like the connector, like the resolver logic kind of helps with that. You have a query, the query says, I have a district, and like I have a city, and the city has districts inside of it. So I hit the query, this says it has a district, and if you don't provide the district data inside of this return that you're giving it, it will look inside of these other resolvers. If there's a district resolver, it will then try to resolve the district inside of this with whatever database you had, and then return the final result back. All right, I'm gonna try to answer these questions really quick because our friend here would like to give his talk as well, so real quick.
How do you ensure the consistency between multiple databases, or is it always eventually consistent?
The consistency is the fact that your data model has to match whatever you specified into your file. Are you saying like that giving one query you're always getting the
How
same
you
result?
synchronize? Well, that's up to you. That's not up to the GraphQL server.
Okay.
So
Is it possible to use recurrency like city has neighbors or neighboring cities, which has neighboring cities?
You mean can an object implement itself, or
Yeah.
like yes? That's actually a thing that we have with our Gorilla auth. The danger is that you can get infinitely recursive with your query.
Yeah.
Yeah.
That's impossible by the schema, because you can't just have an infinite recursion in the schema language itself.
yeah, well, you can produce if you're building your queries automatically through programming your queries yourself, then you can do. You can definitely do a recursive query,
Yeah.
where you ask for example, a user, and he's member of a group, and then you go into the groups and you look for the
Users of a group.
members of that group, and then you get one user of them, and so on. So, and that's why you don't use objects as input, because they could have circular dependencies in themselves. They don't have the requirement as the input objects that they need always to resolve to a scalar type.
So what I think he's saying is that it won't actually resolve that way. Like you'll have a limit of somewhere where your code actually breaks, but in your I think is what you're saying. Like it won't actually let you do that, but in the query itself, you could write an infinite query.
Yeah.
In fact, if you look at our
But
open,
you couldn't send it to the GraphQL endpoint because the schema you define that gets sent to the endpoint and somehow answers is finite. You can't just send an infinite like JSON-like structure.
Oh, you're saying it has to have a finite point, or
yeah, otherwise it will never be complete.
yeah,
Yeah.
we can talk about that afterwards.
Yeah.
We have a specific example we can show.
Okay.
Okay.
Yeah,
So
yeah.
we have one more.
Comment to you. There's a solution where you can analyze depth and complexity of your query. So that's a security for Node or Apple server.
Oh. We should talk to you afterwards.
So there are more things that we want to explore. We have used GraphQL in some small projects at work, but to fully embrace it, we need more battle testing on how you do authorization. Authentication is not that complicated, but authorization, there is, as always, not a single strategy that you can use. So we are exploring that. Also, how to initialize our connectors. We are not that happy with it. And one of the biggest questions is, I have this one single endpoint, and I have this one single server. So how do I load balance this? So we're having a look into that, and more advanced queries where you can use in interfaces or fragments or more of the complex types of GraphQL. What is the stuff that you can do with it?
Cool. And then just I think we'll skip past the Q&A because he would like to get to his talk. We kind of had some questions throughout. Shameless plug time before we say thank you. For you guys' time. We appreciate it, and it's awesome as well. Like we say, we're not really experts on GraphQL. We've just been exploring it, and this is what we found. And we came to have these kind of conversations as well. But shameless plug, if you want to find the notes for this talk or a working small application, if you don't know how to do GraphQL and you want a Node.js implementation, you can go to github.com/HamburgChimps. That's the open source group that we're a part of. And they'll find NodeHH talk that will have all the notes. You'll have an example implementation, and then links for resources if you want to go learn more about GraphQL and Apollo specifically.
And there we have a more complex toy software where we actually show how you can, for example, offer a REST interface to the outside, but in the inside use your GraphQL server to minimize or to ease up the transition. If you're having an REST interface or REST API and you want to support that, but you want to move with GraphQL, you can do that and hide GraphQL underneath your REST interface. And we have some examples how to do that also on Hamburg Chimps.
Yeah, and it's called Gorilla Auth, is the open source toy app that me and Core have been working on. Has some more examples and has this infinite recursion bug and some of the other things that we've been kind of hitting, the problems that you have when you go through GraphQL if you want to see what an implementation looks like with Node.js.
And we're also exploring the authorization, authentication strategies there. How to best secure your data, because as you saw, you have multiple endpoints or you can connect multiple data stores underneath it. So how you actually give access to the data to the user that is allowed to see it. It's not just as an easy question as with REST. I can use the path as for my authorization authentication logic. You have to think a bit more about how you could actually access a data piece.
Since there's multiple ways of getting to one place.
So, because there are multiple ways to getting in one place, so there's no clear way how to realize the authorization part on the GraphQL. But if you have something, please come to us and have a discussion with
Yeah,
us.
and let's talk about authorization and infinite recursion with that guy.
Yeah.
Thank you guys for your time, though.
Yep.